Hello everyone, welcome to my YouTube channel. Myself Hardik Shetty, currently pursuing in first year BE in Sri Venkateshwar College of Engineering, Vidyanagar, Bengaluru. Today we are going to discuss about CAD and projections of planes. The first one is introduction. CAD stands for Computer Aided Engineering and Design. It encompasses the use of software to create, analyze, and optimize a product design. This can be broken down into two main components. The first one is computer aided design. This involves using software to create digital models of physical objects. These models can be 2D drawings or more commonly 3D models. CAD software allow designers to create objects with precise dimensions and specifications and easily view them from any angle. It also streamlines the editing process compared to the traditional manual drafting. The next is the XY plane VP and HP. The XY plane acts as reference plane. Imagine a flat sheet of paper, that's the XY plane. The vertical plane VP is perpendicular to the XY plane and represents the frontal view of the object. You can visualize this like looking straight ahead at the object. The horizontal plane is also perpendicular to the XY plane but represents a view from above as if looking down on the object. Next, drawing views on VP and HP. In a typical engineering drawing, two main views are generated. Top view, this is drawn on the HP showing the object from above, length parallel to the x-axis or represented in true length on the top view. Front view, this is drawn on the VP showing the object from the front lens parallel to the y-axis or represented in true length on the front view. Next, CAD projection of planes. In computer aided engineering drawing, projection of planes refers to the method of representing a three-dimensional plane on a two-dimensional drawing plane. This is achieved by using orthographic projection where perpendicular lines are drawn from the plane to two reference planes. The first one is horizontal plane. Imaginary flat surface below the object. Second one is vertical plane. Imaginary flat surface in front of the object. The resulting representation on these planes are called as views. The first one is front view. Projection of the plane onto the vertical plane. The second one is top view. Projection of the plane onto the horizontal plane. The next is types of plane orientation. There are three main categories based on the plane's orientation relative to the reference planes. The plane parallel to HP. The plane rests flat on the HP. The top view will show the true shape of the plane. The front view will be a rectangular representing the edges seen from the front plane inclined to HP. Then the plane is tilted relative to the HP. The top view will be shortened or elongated version of the true shape depending on the tilt angle. The front view will be tilted rectangle shown the inclined surface. The next is plane inclined to both HP and VP. The plane is tilted with respect to both reference planes. Determining the views requires a step-by-step approach, assuming one plane parallel to a reference plane at a time and then introducing the other tilt. The next shapes that are triangles. These are plane surface bounded by three straight sides or edges depending on specific geometrical properties of the triangles we have. The first one is equilateral triangle, the second one is isosceles, and third one is right angled triangle. The next is polygons. These are plane surface bounded by more than four straight sides or edges. Polygons are of two types, regular polygons and irregular polygons. Regular polygons. All the sides are equal and all the angles between adjacent sides are also equal. Next, irregular polygons. Either all the sides are not equal or all the angles between the adjacent sides are not equal or both. Next, we are going to take an example. Here it is an example. An equilateral triangular lamina of 25 mm side lies on one of its sides on HP. The lamina makes 45 degree with HP and one of its median is inclined at 40 degree to VP. Draw the projections. We should take an XY line of width 0.35 mm and name them X and Y. Then we should construct a triangle of 25 mm each side and select entire triangle and make the width as 0.50 mm and go to rotate option and rotate the triangle and go to move option and move the entire triangle below the XY line and name the triangle A, B and C. Next, extend the triangle's corners to the XY line and select 0.5 mm width line and connect these two projected lines and name the fentus, that is B dash in bracket A dash and C dash. Then select this entire fentu and go to move option and move this fence view and go to rotate option and select this point and C dash point and give rotation angle as 45 degree and go to smart dimension and measure this one side of triangle and go to angle between and measure the angle between these two lines, that is 45 degree, and project these lines towards downwards. We should take 0.13 mm width. Now extend these corners towards right side and take 0.5 mm width and connect all these points. We get a triangle and name the triangle A, B and C. Now take an line of 0.13 mm and from XY line draw an 40-degree line. Go to angle between, measure the angle between XY line and this line. We get 40 degree and go to a point and locate a point on 40 degree line and go to arc by center point. Select 0.13 mm width and first go to smart dimension and measure this front view. We get 21.65 and go to split option and split this median and measure the median. We get 15.31. Go to arc by center point, take reference as this point and give radius as 21.65 and cut an arc on 40-degree line and go to line and select discontinuous line and draw an locus. Next, go to arc by center point, select continuous line and select this point as reference point and give radius as 15.31 and cut an arc on this locus line and join this line towards this point and go to extend to next option and extend this line towards xy line and go to smart dimension angle between, measure the angles between these two lines xy line and this line, we get 60 degree. Next, go to select option, select this entire triangle, go to move option, select C point and project this C point on this point and go to rotate option and select this C point and this median and rotate this triangle and go to line and select 0.13 mm width and project these corners towards upward. Go to trim option, trim unwanted lines and go to line and select 0.5 mm width and join these triangles and name the triangles E dash, B dash and C dash. And this is an example of an projection of planes. Thank you. For more videos, subscribe to my channel and please like the video.